winter. Have you looked out of the window, Melissa?
No, I know it snows, but I haven't
No.
looked outside yet.
No,
That's
you should do it, definitely.
okay.
Yeah, it's really like a winter tale. We don't have it often in Vienna. Yeah, so today it's two of us, Annalisa and me. We're gonna talk about something related machine learning, data science. And first of all, yeah, we're XTechnology. We're the community of people who care about IT technologies or informational technologies. We learn and share new things. And today we are here, I don't know, both to learn and to share. So the idea is that we want to use Azure Machine Learning. So that's the tool from Azure. It's one of the services that they have in their cloud. And today we are gonna create or build a small classification model, and we will deploy it as an endpoint in the machine learning, in Azure Machine Learning. So this is the plan for 1 hour. Again, this is like this the session when we try to keep it short. And in 1 hour, I guess we just should put a hard stop. If we're not finished, then who cares? We'll do it next time.
I haven't used Azure Machine Learning for over a year, so I'm here to learn.
Same for me. Yeah. No, I'm kidding. Actually, there are like some news in Azure Machine Learning. They released the second version, so Azure Machine Learning V2, SDK V2, and they really encourage everyone to use it. But I'm an old and slow person, so I haven't tried it yet.
Okay, so you will try the new version today.
I'm not sure, honestly. So because with the old version, I think we would be able to do it in 1 hour, but with the second version, not sure. But let's
Okay,
see. So
maybe we
yeah,
start with the first, and then
yeah,
the old version, and then if we have time, we try it out.
totally. Yeah. So let's start with the. Let me share my screen. Yeah. So now I already created an environment for us, and let me make it a bit bigger. And I think this should be enough. If I put my bookmarks away. Yeah, so this is machine learning, and there are a lot of different stuff on the left, and I already created the compute, so the instance we will use for calculations. And we can, so what I like to do, I just like to work in Jupyter or Jupyter Lab. I will click on Jupyter Lab, and we'll start with notebooks. So I picked a very popular and notoriously famous data set. So it's a Titanic data set. I just found the link for it. And yeah, because it's not complicated and it has all types of variables, categorical, numerical, and so on. So let's just start with it. I will go to my, I already created some file, but let me delete it. So we will create a new file using the pre-default environment, Python environment. So Azure Machine Learning comes with predefined environments. So if you don't need anything super fancy, then you can use one of them. So the first one is the most usual for just machine learning, usual machine learning, no deep learning. They also have like a PyTorch and TensorFlow version. And now recently they have this SDK V2 version.
Okay, so with the new version of Ubuntu.
Yeah.
What is Python IP kernel? So there is a Python notebook kernel, but is.
Yeah, honestly, I don't know. I don't know. What is it? Maybe that's like an empty kernel, but I'm not sure because here we have a lot of libraries already installed.
Okay.
Yeah, and also Azure Machine, like Azure SDK installed. But just for the sake of simplicity, I suggest we can go with this one, at least for the model training. Yeah. And so, yeah, let's rename the notebook. Model training. It's again not big enough, right? Let me make it huge. Okay, so what the data scientist is doing first? Any guesses?
Import the packages.
Exactly. Yeah, and import which package?
Well, you probably need to import the Azure ML SDK.
I will start with just
Scikit-learn, pandas.
yeah, exactly, pandas. Yeah, let's start small and just import the
NumPy. I
file.
don't know if you need it.
Yeah, maybe we need NumPy, but I'm not sure yet. So let's start with pandas and just look at the data. So pd read CSV, and it's so cool that it can read the HTTP URLs. So yeah, I already copied this Titanic URL, and yeah, it was able to read it. So we have the data. And yeah, I don't know if everyone's familiar with this data set. Basically, it's the list of all, or maybe most of the passengers from Titanic. They have a bit of some features like their names, the sex, the age, also which class they were, which cabin, how they embarked. I don't remember what C and S mean. Also some tickets, yeah, some ticket stuff. And so the main target here is survived. So it's either 0 or 1. And we can look at the very sad statistics, I guess, of what happened with the passengers in Titanic. Well, actually, yeah, I mean, it's kind of sad that 62% of them did not survive. And yeah, so, but it's not skewed, very skewed. So yeah, 38% of the passengers survived. And our goal is to build a classification model which will tell us who of them will survive.
Yeah, to predict the probability of survival.
Exactly, yeah.
Can you show maybe already the mean between man and the female, male and female, the mean of the two?
Yeah.
Just to get a preliminary idea.
Yep. So we can do maybe a group by gender, or sex it's called, and then survived. I mean, I think it will look like this, yeah.
Okay.
Yeah, I mean, that's how it's supposed to be, I guess. Yeah, so they try to save females, like women and kids. Yeah, there's no, there's age actually. Yeah.
There's age, yeah.
I mean, we can create ranges of age, but it's like a numerical value, so I don't remember.
I guess we will look at that in the...
Yeah, like from the top of my head, I don't remember how to visualize it the quickest. Yeah, perfect. So what do we do? So I mean, there are not too many features, and I think we can just manually go through them, and I can create. Yeah.
No, I was saying then there are some features that we would expect not to matter, and also some, like for example, the passenger ID and the name and the ticket, they probably have a one-to-one relationship, and we don't really need them.
Yeah, totally. So basically, it's just an identificator, the same as the index.
All of them seem like to me. I mean, I don't know about the ticket, if maybe families have the same ticket number, but I wouldn't say so. Or I wouldn't consider it.
Yeah, I totally agree. So yeah, passenger ID, name, and tickets, that's probably information that we cannot really use, not to overfit or underfit. I don't know, probably overfit. And basically, it's not that much left. I will just create like a list of the features, and I will put the features that we might use. So P class, I guess that's I don't know, platform, a passenger class probably.
Yeah, I think that's
Yeah. I'll just
kind of an indicator of wealth, maybe.
Yeah. So we have a passenger class. Then we have the name we skipped, and the sex and the age.
I have no idea what SIB, SP, and PARCH are.
Yeah, actually, that's a good question. So, I mean, we can Titanic data set description. I don't remember, but we can have a look. Titanic data. So yeah, it's on Kaggle and columns survived. Oh, come on. Yeah, that's a data set with only 2 columns. Is there a beginner's guide?
I also look.
Yeah, let's take the first one. Yeah, okay. So yeah, this SB, that's a number of siblings supposes a board.
Oh, okay.
Interesting. Yeah.
Number of
And
parents and children. Okay.
yeah, parents and
Siblings,
children.
spouse, parents, children.
Yeah, so quite a nice data. Yeah, and regarding this passenger class, there are 3 classes: first, second, and third. So Jack was the third, I guess. And what's the name of
Yeah.
Rose? Yeah.
Rose, I think her name was Rose, was first
Yeah.
class.
Yeah, she was the first class. Okay. Right. Okay. I see here there are a bit more
Yeah,
features.
you can see Lifeboat in the
Yeah,
dataset.
like both body. Yeah, maybe there is like a more full data set of Titanic, but yeah, I didn't know honestly, and we will have not the full one, but we'll work with this one. Okay, so basically siblings feature, this parents, children, ticket we won't take, fare we can actually take, although it's probably correlated with the passenger class. But who cares currently? Machine learning is smart. Cabin. I forgot what is cabin. Cabin is cabin. Okay.
I don't know like how much it can help unless we can use cabin to extract some information about the location on the boat.
Yeah, maybe it will.
But just like this, I don't know.
Yeah.
I don't know if it would be
Yeah.
helpful.
Yeah, I honestly don't know. Let's for now not throw it away and see. And also we have this embarked. That's the city where they embarked, I guess. Yeah. So it's Southampton, and yeah,
Or
Cherbourg and
okay,
Queenstown.
that might be
Yeah,
important.
that probably. Yeah, I don't know. Somehow it maybe relates on the cabin, but I don't know. Yeah, and so I will just put the target. Target is survived, as far as I remember. Yeah, exactly. So I see that the dataset is kind of already nicely prepared. There are not too many missing numbers, although this cabin has nuns, not the numbers. And for this, actually, maybe it will make sense to split the features in categorical and numerical, because we would like to do the imputation, and the imputation will be a bit different. So yeah, it's like a bit of manual work, but with that amount of features, I think it's not an issue. So let's create the. Oops.
For numerical, we have age.
Yeah, so it's basically only age and
I don't know
fair.
if CBSP and Parch are number of siblings and spouses, or is a category, yes or no?
Let's see. So if we take CBSP and whatever counts, yeah, it's categorical or ordinal. Yeah. So we can say that it's numerical. P class, it's kind of
categorical, I would say.
Yeah, it's more categorical. Yeah. And parent children, I guess it should be similar to this. Yeah. Oh wait,
So,
is it the same?
Wait.
Was it identical, or I just did something wrong? CSP. No, not identical, but just similar. Yeah. Yeah. Okay. So age. Yeah, basically this 3 This 4.
Yeah.
Yeah,
I would
so
say
like
the
this.
same.
Yeah, and so the rest will be categorical. And I will just say that feats equals the sum of this.
Yeah. And in Python, when you have two lists, then when you do the sum, it concatenates them.
Yeah, exactly. Yeah, so it's not very
It doesn't really
straight.
sum. It's
Not
always
too straightforward. Yeah, yeah, but I'm so used to it that I don't even think that it could be weird. Yeah, so let's now. So I think for the classification model, we won't need any smart processing. I guess we will need just the imputation and maybe standardization, but not really sure. So we will need something for imputation for sure. So from SQL, where's my SQL? Yeah, okay. SQL, yeah. I always forget where it is. Preprocessing?
I also don't remember. If I think
There's no
processing, but
simple imputer or
learn impute.
yeah, impute.
And
Okay.
then simple imputer. From sklearn impute, import simple imputer. If we want to do simple impute
Yeah.
in this case.
Yeah. Yeah. Right. So this is a simple imputer. Then we might need, or we will definitely need some model from sklearn. I guess we can start like small and use a linear or logistic regression.
I would say so, yes.
Yeah. Okay. Then it's from linear, right? Or logistic regression. Yeah, but if we use logistic regression, then I guess we need to standardize.
So it's linear.
Actually,
yeah.
Yeah.
Perfect.
Just yeah, I guess it will make sense to make a normalization. From sklearn this preprocessing. I always try preprocessing. Yeah, standard scalar. I guess standard scalar should be enough for us. Okay. Yeah. So we also have to split the data somehow. Yeah, I'm so used to copy pasting all of these things.
Yes, I'm thinking the same. I wouldn't remind you.
I have no idea where train test split is.
Train test split is model selection.
Model selection, I guess. Model selection. Wait, I'm tapping.
Model underscore select.
Train test split. What else? I mean, probably we don't need cross validation for now. It's not too many.
I would like to have the confusion matrix at the end.
Yeah. So and the metrics, of course, yeah. So
And the matrix, yes.
Yeah. All right. Sklearn metrics import AUC. Wait, how it's called? Yeah, a rock basis score. Confusion metrics. Yeah, maybe for now. Let's stop at this. Okay. So maybe we will need also pipelines if we
do it with
yeah. And then oops, what is SQL to index? I don't know what it is. Yeah. Pipelines. Import pipeline. Great. So now we imported everything. Let me close it. Data head. By the way, what's the size of the data? Well, it's pretty small. So 900 passengers were on board. So this will I delete. This will I also delete. And so I guess first we can split the data in train test, and then we build a pipeline, and we go from there.
So with simple imputation, How is the imputation happening? And then like you do it separately from training, and like first for training, then for test, right? Because we are kind of recreating a real life scenario and we wouldn't
Yeah.
have to test.
Yeah,
Okay.
exactly. Yeah, so I think that it will be just nicer. What we could do, yeah, we could just take the whole data set and impute based on the statistics of the whole data set.
But
But
then
as
we
analysis,
you.
yeah, but then as analysis set, yeah, it makes sense to do it like in real life, so that you have the training data set and you train the model based on the statistics on the training data set, and then when you want to score something, you do the preprocessing based on the statistics again of the training data set, but apply the data from the test data sets.
Yeah, because you
Was,
always have to imagine that in real life, like if you were to do this in a business setting or so, then you will get data that you have never seen. So how would you do it? Then you would take the same, and you wouldn't want to reproduce exactly what you did for the training test to have some security that what you're doing makes sense and then has the same properties. So you would say you would take the same transformation you did in the training test and then do it to the new data.
yeah, exactly. Yeah. Yeah, I mean, maybe first of all, we need like X and Y, right? So data, I call it target, and X data fits. Let's rename it to fits. Yeah, now we can say X train. Yeah, that's the longest stuff I have to write. Test equals to train test split from X and Y. And so what is the, oops, what is the parameter? Oh, it doesn't, test size, yeah, test size.
The size and then
Yeah, maybe like usual
0.3.
Yeah, yeah, oh, yeah, oh, actually, I should go to 25.
Yeah, because the data set is kind of small, so yeah, okay.
Yeah.
Optimizing.
Yeah, and also we can specify the random state, or it's called
I
random
think it's
state.
random state.
Yeah, random state, and let's also create this variable seed. And is it 42 or something smarter?
42, yeah.
Okay, yeah, not
The
trying to
meaning of
invent.
life.
Yeah, the meaning of life. Yeah, now we have all these small parts. And what we can do, we can actually maybe not, let's not build the pipeline right away. Maybe let's try to do it a bit visually and see. So first we should do the imputation, right?
Yeah.
So yeah, let's initialize the imputer. And actually we will need two imputers, like for numerical and categorical.
Yep.
So because we will have different strategies. Simple imputer, and
We
here
can also, before imputing, see if, because maybe the missing values are only in
yeah, actually
right.
data.
Just this will save us some times, I think.
Describe probably won't show us. Yeah, is an A.
Is an A, yeah.
And
And
maybe we
some.
can go. Yeah, you're right. So H is numerical and Kevin is categorical, right?
Yeah.
Yeah.
If that's okay, I
Yeah.
mean, you can also do it for everyone. It wouldn't change, but it's just a bit faster.
Yeah, but you're right. So maybe if it would have been only in numerical or only in categorical, then we could skip one. But I guess, yeah, let's just introduce both of them. And for numerical, we will need maybe just within, I don't know, we can use just the mean for the age, or is it fair?
It depends, but I mean, I guess we're doing things simple, so let's just do it.
Yeah. Actually, it's default, but I will just specify it so that we will see it. Categorical. Yeah, we can do mean for categorical. We will need a field value.
The max, or what is
Sorry?
what is the strategy usually? So we fill the value, or we can take the max.
The max, or I mean,
No, I'm just thinking. I don't know what the simplest strategy is.
Yeah, I think the simplest strategy is just to fill it with value, which is weird.
Okay. Or yeah, okay.
Yeah. So fill.
So we would have a category for missing, basically.
Yeah, basically like this. Yeah. So we can say fill value, and we can just call it empty. So yeah, I mean, it's a bit weird because we have in categorical features we have p class, which is actually a number, but we want a model to think about it as the category, right?
Yeah.
So I think for this we will need
To convert to
yeah,
encode, right? One hot encoder probably.
yeah, exactly. Is it in preprocessing or yes? It's in preprocessing.
It might be ordinal also because it has the meaning.
Yeah. So yeah, actually, p class has the meaning. What else do we have? Sex doesn't have a meaning.
Hopefully.
Been...
Well, in this case, yes.
No, I mean not ordinal meaning,
Yeah.
sequential. Yeah, and cabin and bark also don't have. Yeah, p class is actually I don't know. We can make it. We can create like a separate.
I mean, but since it's only 3 classes, I think we don't like it's okay to just treat it as categorical, not ordinal, because
Yeah.
anyway, then you can always look at the difference for the results between the different classes, and it's kind of interpretable. But if it was a lot of classes, then I would consider
Yeah.
ordinal.
But still, for one hot encoder, we will need I don't know. So we can say that we have fit cat ordinal, or just maybe ordinal. And I'm maybe hard coding too much.
Yeah, I think it's good because then is easier to follow.
Yeah. So p class, and then let's do this. P class fit ordinal. Yeah, because for ordinal we will need one hot encoder, and for the actually we will need for all of them.
No, for categorical you need the one hot encoder. Yeah, cool.
Yeah. Yeah. Okay, so where were we? I will delete this one. So empty. Should we maybe use a different strategy for this one, or it's gonna be okay? Empty. Yeah, let's just do it. Yeah. So we initialized it, and now computer. Let's start with numerical, and we can do fit transform right away. Oops. Fit transform. Actually, yeah, it will output us x. Oh wait, fit transform will get the x categorical.
Yeah, explain.
Oh yeah, xtrain, exactly. Xtrain, and we can say like this.
Perfect.
Yeah, and maybe we can do right away. Categorical. Wait, now we will. Yeah, now I think I did it.
I think you forgot the one hot encoder if we want to do the one hot encoding of the categorical before imputing, right?
I think we first could impute and then do one hot encoder because.
Okay. Yeah, you're right because we put an empty there. Yes, sorry.
Yeah. No worries. I'm just thinking, do we really need this ordinal?
No, I like
Yeah.
simplicity. I would leave it in the category.
Yeah.
Right
I think it was overthinking.
Also because we have a hard stop at 11.
Yeah, and I'm already a bit worried regarding this hard stop.
We'll get there.
Yeah. Categorical. Oopsie. It's just warnings. I mean, if I do like this, I don't know if it changes anything. I hate these warnings. Let me redefine it. Oh, it a bit less. Yeah, I'm
Also there.
a perfectionist, unfortunately. Yeah.
Perfect.
Yeah, it doesn't help. Yeah, I
Why?
don't like this. I don't know, because sometimes these warnings just can't help but show up. I think it's also in their docs.
But try using .logs, row indexer, call indexer is exactly what you did.
Sorry, what should I do?
No, it's exactly what you did there, right?
Yeah. But I think they also say in the documentation that sometimes they cannot grasp what you're doing, and they will just show this warning just for the sake of showing it, and whatever. But I think if we look at extrain,
it's fine. Yeah.
Yeah, you see we have empty, and we have h. Yeah, I don't know. Maybe somewhere is the. Yeah, I guess this is the mean, because it's a weird value, and it's always there. So yeah, I guess this worked. Now we also need one hot encoder, right? So let's initialize it. One hot encoder. Categories auto drop sparse. I think we don't need anything additional. Let's just initialize it. And all hot encoder fit transform from XTrain fit categorical. Categorical, and that's gonna be our not really, but it's because it will look like,
because you will have more.
Yeah, a little more, and this is like how I usually do it. I already forgot. But by the way, it's
Yeah, just add it to the dataset and get rid of the original one, right?
Yeah. And yeah, I also see that we have 123 classes.
Oh my God, why?
Yeah, I guess that's because of the cabin, maybe. Too many different cabins.
That's too many, yeah.
Yeah, so maybe it will just too much for 668 rows.
It is too much, yeah.
Yeah, let's just get rid of this cabin.
Yeah, I agree.
Yeah. So it's one hot encoder, and now it's 12.
Okay, perfect.
Now it's 12, and just yeah. Sort of now one hot encoder. Guess we can say that it's, I don't know, X terrain encoder. Yeah, now what else do we need to do? What else? Yeah, we need to use a standard scaler. If we want to use a simple linear model. So scalar equals, also by default, yeah, copy with mean. Yeah, let's just leave it as it is. Yeah, and then scalar fit transform x terrain fits numerical. Numerical, and then let's comment this, but with Okay, now we have to. Yeah, actually, probably it will make sense to do it right away for test, because we will check the test. And for, yeah, let's do it for imputation first. So test x test numerical. So for this we don't need to fit, we just need to transform.
Yeah.
Yeah, and this, and the same for categoricals. Categoricals also here. Test. Oops. Transform. Test. Actually, here maybe you see it by default. It initializes it with handle unknown error. And yeah, so basically, if it's in the test set, it will see in category that it didn't see in the train. It will throw an error.
Okay.
Maybe we can change it. I am pretty sure it won't happen in this data set, but let's just put it to ignore.
Okay. And what would it do in that case?
I think it will. It's a good question, actually. Let's check ignore. Ignore whether ignore if an unknown category is present during transformation. When this parameter is set to ignore and it's encountered, the resulting for this will be all zeros.
Okay.
Yeah. Maybe not the best. Yeah, it should be done differently, but
yeah, we can.
Yeah. Okay, standard scalar, the same. Standard scalar test. Scalar fit transform fit and okay, yeah, let's just rerun. Yeah, maybe I initialize them all in one. Let's rerun it, initialize all of them. The imputer, the one-hot encoder, and the scalar. Oops, something bad is happening.
This is an error.
Yeah, what's wrong? Fit numerical. Lengths. Oh, I missed the train and test somewhere. I guess. Yeah.
Yeah.
Yeah, so let me just run this. Okay, so now, yeah, and now X train, I don't know, merged equals, what is the fastest way to merge the data frames? PD concat, right?
Oh, concat, yeah.
PD concat.
Concat, and then you have to say the axis. So axis one.
Yeah, exactly. And for this, what is it? First fit numerical fit. Basically only numerical and categorical one hot encoded, right? So X train fit numerical and this one.
No, I think you should use the one you called them then. Like X train.
Where?
No, sorry. Can you go down a bit? So I think you, oops, because you have, yeah, because you called them, you already, okay, no, that's correct. Completely
Yeah,
correct.
we kind of overrode
Yeah,
here.
I missed that.
Yeah, yeah. Maybe it's not the best strategy to overwrite your values, right? Yeah. It's train and it's test. Nope.
Oh no, what did we do?
Something went wrong. It cannot. So it's like a sparse matrix. How do we convert?
Is the why is it
Yeah.
sparse? With the one
Yeah.
hot give
Yeah, I
you
think by
a
default.
sparse matrix. Okay.
Yeah, I think there is a fast trick. Is it values or to list? I forgot.
I also.
To array, maybe. To array. Yes. Oh, but that's not the. Oh my God, that's not the data frame.
So it's a sparse. Oh my God. That's the problem. Okay, so you need to make. Okay.
Yeah, I hope it won't be too bad. Get feature names. And input features. Is it the same length? So we have shape 12 and here 12. Yeah, so I hope it will work. So these are the cat names. And this one, let's just say like this.
Let's see. Yeah.
Yeah, I'm not sure if it will work now, but also, and now how to quickly create a data frame out of data and yeah, let's try just frame button folder and columns.
I think it's columns.
Yeah, I think columns. Columns equals to techniques. So let's run this.
Columns, yeah.
Yeah, looks kind of valid. Not
Okay.
sure.
Yeah, perfect.
Yeah.
Yes.
Yeah. Okay, then let's save it like this. Also do the same for test. Unfortunately, it's kind of a bit meaningless because we won't use it in pipelines because pipelines won't need it. But for the sake of visualization, it's, yeah, I mean, at least I don't. I'm not like a test-driven developer, so I usually look what's happening after every step that I'm doing, and that's why I go this
Well,
way.
wouldn't you anyway need to understand what the pipeline would do?
If you're an engineer, probably you don't need. But
Okay.
no offense to engineers, yeah. It's no offense. That's not something bad that I meant. But yeah. Okay, then I guess now we should be able to merge them. Let's try once again. Yes, and let's see how it looks like. Okay, so we have H with, oh my God, how did we get it?
Normalization.
Oh yeah, I already forgot. Okay, yeah, that makes sense. Yeah, what is X? Why is it called X0? It doesn't know the name. Okay, we can do something like feed cat here. Oops, we cannot.
No, leave it like that. I mean, it's which category? Because for female is clearly so this is female, then you have it for the starting thing. You know, there is _1 and this is the class.
Yeah, I just wanted it to rename X0 to the names.
Okay. Now I got it.
Yeah, but just input features. Feed cat 3.
Why didn't it get the name? Because for female and male, it got
it cannot kind of grasp it on its own.
Yeah, true.
Let me.
We should have set class 1, class 2, class 3, but
yeah. Well, let me just try to run it. I think it should work. I don't know why it doesn't currently. No, it doesn't. Input features, number of features. Not hot encoded. Got 3. I don't know why it asks for 4 features. We have only 3 features. Let's see this one. We cannot see. Because the first feature is P class, right? Then it's sex, then I forgot the embark import, and that's it, right?
Yeah.
But why it's looking for 4?
Yeah, I'm wondering what is that. Yeah. Can you have a look into FitCat?
FitCat, yeah, FitCat should be our P class. So yeah, it says that it got 3, right? But it wanted 4. But why did it want 4? Because xtrain fit 3 columns only, no? Wait. What?
P class is 2. times.
Oh my God, yeah, that's something wrong that I've done. Let me initialize the data.
Let's just rerun it.
Yeah, let's do this. Pam, pam. Let's see. What?
I don't. I can't hear you anymore. Yeah.
Um, it shows.
Igor, I can't hear you
Okay.
anymore. I don't know if it's my connection or yours.
Yes.
Okay.
Do you hear me now?
Yeah.
Is it okay? Yeah, because it showed me some weird stuff. And
Yeah. Now you're back.
okay, yeah, I just want to see. Oh, we already have 2 P classes. Music strain.
I think so. Here you should get rid of fit ordinal,
Yeah, exactly. Fit ordinal.
and then you added up. Yeah, exactly. And I think here is the trick.
Yeah, you're right. It's yeah. Now it should
I
be
think
good.
we'll put it into production. We'll deploy it next time.
Yeah. So maybe till next time I learn the SDK v2 or something else. Let's see. One hot encoder. Yeah, let's see. Yeah, now it should work, I guess. Yes, it did work. And to array. Yeah, let's just put it in here. And this one as well. Yeah, let me just do all the one hot encoding stuff into one cell. Number xmerge. Okay, xmerge. Yeah, now it looks like p class 1, p class 2, pam, pam, pam. So yeah, I spent 10 minutes for mostly nothing, but now it looks nice.
Ooh, perfect.
Yeah, so now we can finally train the model. Let's get rid of this. Let's say training. Yeah, I don't know why I decided to comment now, but not before. Model, logistic regression. Logistic regression. I guess no parameters needed. Oh my God. Yeah, at least let's start with no parameters. Yeah, distribution, feed on the tests or on train. It's just y test train. Fit. Oops, no, something already is wrong.
I mean, this is test-driven development.
Yeah, in a way. So where are these NAs?
There were NAs, but I thought NAs were
Yeah.
just included
Oh my. What
in
did I
all
do
of
wrong?
them. What?
What did I do wrong?
And all the same number in all of them? Oh, this is weird.
That is very weird.
Look into the data set, yeah.
Yeah, I think this concatenation.
But isn't concatenation only on column? Why did we concatenate? I mean, why did that not work?
I'm not sure, but maybe it shouldn't be XS1. Maybe it should be XS0. Let's see. Oh no, it's a bit wrong. So it's XS1, but
Okay,
it shouldn't be that much, right?
no. So basically, that access. This should just take the two data frame and put them next to each other, right?
Mm-hmm.
And I thought that was concat.
Because of the indices, I guess.
Because
Yeah.
of the index, you need to reset the index first. Yes.
Yes. Okay, let's maybe do it in here right away. so it's already in here. Ah, no, here the indices are normal. Yeah, so
It's here.
these indices, yeah. What is the quickest way to do it?
I think in the options there's something of train trace split.
Yeah.
I think.
Maybe fits size, train random state, shuffle. Whether or not to shuffle it before splitting.
Yeah, no, we shuffle it, yeah.
Yeah, but we want to shuffle, yeah.
Yeah.
Return splitting.
Okay, no? Okay.
Okay, yeah, let's do it manually. Yeah. Strain, strain, it's called drop, right? And the same for test. I think we don't need to do it for wise. I think it's not needed. Yeah, let's run all of this, all of this, all of this.
Oh.
Yeah, now we don't have any's. At least, I mean, we kind of did 668 rows instead of 900.
Yeah.
And
Perfect.
let's try to, yeah, 0, 0, 0, 0, 0. And delete it. Let's feed the model again. It did fit. And
Woo!
now, yes, predict proba. Oh, we almost have it. We almost have it. Test merged. And that will be our predictions. Oh, actually, I usually do like this. So it's, oops, I think it's like this. Right?
I have no idea what you're doing.
Yeah, yeah. So, yeah. So predictions look like this. So for every prediction,
okay,
it
okay.
outputs the probability for the zeros class and the first class.
Mm-hmm.
And I guess we want only the first class.
Yeah.
The probability of being survived.
Yeah, then you're
And
right.
I think it's like this.
I think it's 0. No, 1 because you want the probability.
Yeah,
It's
like
the probability of
the,
being 0 and then the probability of being 1. Yeah. Oh,
yeah.
woo! We have it.
Yeah, okay, so now we have predictions, and what we can do, we can calculate the metric. RCC equals, oops, yeah, score. First we put true values, that's test, and then we put threads. Yeah, we also have to print it somehow. See. Wait. Yeah. Oh, 87%. It's probably too much, but we're smart, right? Yeah, and we can have a confusion matrix. Confusion matrix. And for this, we need white true. Oh, test. And predictions, but predictions we will need to put the class. So 0, 1, we cannot put probabilities because it doesn't work with. Yeah, and we have to pick the threshold.
Let's start with 5 or like usual.
Yeah, I mean, we can start with the usual one. And yeah, oops, no, that's not it. Something is wrong. The type int, so this is an integer.
Maybe it's a boolean. This is a boolean probably.
Should do like this. Wait. Yeah. Let's see what it is. Yeah. Okay, it's not
Again.
Yeah, I forgot. Yeah, I forgot one letter.
Yeah, so.
Perfect development. Yeah. So here is our confusion matrix. And
so can you go there like to what that? So there's 115 that were dead, and we identified a dead. 64 that survived. No, sorry, 115 that. No, I don't remember what was one. One was survived or dead?
Yeah, one survived. One is survived.
Okay, so 115 that were dead and we identified dead. 64 that survived and we identified as survived, right?
Yeah, and we have, so these ones are really dead, but we said that they survived. Oh, that no. No, the other way around probably. I always forget where is where is what. I mean, we can play around. So now, So now everyone survived. We have more false positives. So these are false positives.
False positives. Okay.
Yeah, and
So they dead
like,
and we say they survived. Yeah, makes sense.
yeah, like more FPs and more false negatives. We should go like here. Yeah.
Okay, makes sense.
Okay. Yeah, I mean, it somehow works. What we could do in 3 minutes, nothing probably. I thought that maybe we can create a pipeline.
Yeah, we can do that.
Okay, let's pipeline.
So can I maybe in 3 minutes you can answer a question? So we need the pipeline for the deployment.
Yeah, exactly.
We
Yeah,
need the
because you.
deployment without pipeline.
Yes, we can actually. So for the deployment, we can deploy the model or the whole pipeline. So in this case, for example, we train the model LR, and now it's like a logistic regression, and we can just deploy it to some endpoint.
But then we would need some pre-processing also on
Yeah,
part of the inference.
exactly. Yeah, because all that we have done here, like in this cells, we will have to re-implement for the data that we want to score. And it could be the case, yes, but I think the best strategy is to put all this preprocessing into the pipeline. So that's when you want the predictions, you just put the initial features, and then this pipeline will preprocess them and do the prediction, run the inference of the model.
Makes sense.
Yeah.
Okay.
And yeah, I don't
Can do it.
know. Yeah, I mean, let's try. Let's maybe try to stop at 11:05.
Okay.
I'm pretty sure that I won't finish it till that time, but at least I could try. So pipeline. I think it is defined like this. So so we first of all we need like we have numerical and categorical features, right? So we can say pipe numerical equals some pipeline, and it has steps. I think it will have 2 steps, like impute and normalize. Impute, impute. That's just a name, and
So this is the name
scale.
that we are giving.
Yeah, and here we will put the what we did exactly. So the transformer itself. Where is this imputer? So we can copy this. Sorry. One training. Yeah, I will just copy it here.
So
Some
that's
point. Yeah. So then scale, standard scalar. This
I have
will
a
be.
stupid question. Could you put instead of that already so the imputer cat like imputer num like you defined it?
Yes, I can. Yes, I can. Yeah, actually, we can.
No, yeah, I just have no idea. That's why.
Yeah, no, we definitely can. Yeah,
Okay.
just maybe we don't need to define the variables which we don't use.
Okay.
But yeah, we can do it, of course. Yeah. Then categorical, it will be just a different attributes of the imputer, and we don't need to scale.
No.
We do have to do one hot encoding. Right?
Mm-hmm.
One hot encoding, and for this we do this guy. Okay, so these are 2 steps.
Then there is the concatenation.
Exactly. Yeah. I think. Yeah, I'm actually looking at my kind of quick and dirty version of what I've done before in different projects, and I used this column transformer thingy. So for concatenation, exactly. So like the pipe preprocess equals, we have to import the column transformer from sklearn compose. Yeah, I would never remember it myself. Compose, import column transformer.
Okay. And what does column transformer do? Just transform the columns based on the autoencoder and like gets rid of the.
Actually, not only. So it is able to combine different pipelines. I don't know if we open that.
Okay.
Yeah. Okay. So yeah, it applies transformer to columns
Or subsets, which I guess
yeah,
that's
or
what's
subsets
cool.
of columns. Yeah, and
Yeah.
also
Okay.
yeah, and it kind of you can specify which columns to use to which transformers, and then it will merge them. So yeah,
Okay.
let's maybe it will be a bit more understandable. So here we will merge first the, like we call it, process, process numerical, and we put here this pipeline which we've already created, and we specify the columns which we wanted to apply it for. So it's numerical, and then the second step is the same for categorical. It's categorical, pipe categorical, and then it's categorical. And so with the steps, it's enough. And it also has one parameter, remainder. So that's, so here we specify that we want to do something with numerical columns, with categorical, but if there are some additional columns that we do not want to transform,
you see what you do with those.
Cool. You can say, and default is drop. But also, it's either drop or pass through.
Okay, then I guess it's pass through in this case, right?
Yeah,
we don't have any other, but still.
Yeah, but I think it's, we can say it. And actually we can also create the pipeline which will be combined with the model. So pipeline final equals, let me just copy. Okay, copy pipeline. So 2 steps. First, the pre-processing and the model. So pre-process, then it will be this pipeline, and the model, it will be, we have to initialize the model. Let's say that the model equals acoustic regression. We don't need a need. Yeah, we can do
okay. Now that's cool.
Yeah. So this pipe final, if we run it, it will of course throw some errors. It's none. I think it's a fit num. Yeah, sometimes. And now we have this pipe final, and we can do pipe final dot fit.
Okay.
Yeah, like with
the original
train. Yeah, it was the original X train and Y train.
No, wait, with the test. No, you do it on the train too. Okay, super.
Yeah,
okay, now I got it.
Yeah, but something happened. Failed to converge. Something failed to converge. Logistic regression failed to converge.
Interesting.
Yeah, let's see, is it able to run some predictions? Predict proba X test. It does output, and I think it looks the same as it was, like 8712. I think it was the first value there. I don't know.
You don't have to fit transform, right? Because he's kind of assumed that he's gonna at the beginning transform and then.
Sorry, could you say once again?
So I don't have to do fit transform on.
Yeah. So it will understand it on its own. So
you need to transform before passing it forward.
Yeah.
Okay.
So now it just knows, and it knows that it consists of transformers, and when you do fit, it will all do like only fit.
That's cool.
Yeah, and then
It is
transform.
interesting that here it didn't converge on before it converged.
Yeah, I'm not honestly sure what's
Or
what's
scale
wrong.
the data. We put the scaler. Did we put the scaler here?
Yeah,
Yes.
so the scalar is here. Handle unknown. Yeah, I mean we can try a different algorithm.
Yeah, but I think is 11 or 7.
So oh yeah, it's 11 to 7. Okay. Well, I mean we kind of created the pipeline, and predictions are yeah. So yeah, just quickly, if we run the ROC score on tests and predictions, it should look 86, and before it was 87. Yeah, I don't know.
No.
Something happened. There
Yeah.
is a warning. Yeah, but yeah, we kind of Just to recap what we did. We took the data set of Titanic data. Then we looked a bit at the features manually. So we split them in numerical and categorical. Then we did some pre-processing. So for numerical features, we did the imputation with a mean value. For categorical, we imputed with just a value called equal to empty. Then for categorical, we also did one hot encoder. And for numerical, we standardized or scaled the features. Then we merged all of what we had, a lot of code, and we used logistic regression to train the classificator. And we achieved 86, 87 area under the curve. And so that's what we kind of did. Unfortunately, we didn't really dive into Azure ML itself. But I guess that means that we will see you soon again. And hopefully, we will be able to deploy it. And maybe we'll deploy it with SDK v2. Let's see if I am prepared. If not, we'll use SDK v1. And Annalisa, I heard that you would like to deploy it with Fast API. I heard something.
Yeah.
Yeah, so let's see. Maybe we'll use
Oh,
multiple.
maybe we could like create an endpoint with Fast API and then see the difference and like.
Yeah.
Oh, this would be cool. Yeah, let's do it. It
Totally.
would be cool also to try with like AWS or Google Cloud or like IBM Cloud and like see how the
Yeah.
user experience is.
Yeah. Totally. So the possibilities are just
Endless.
endless. Yeah. Perfect. Yeah, but let's wrap it up. Thanks a lot for everyone who's watching it. Thanks a lot, Annalisa, for being a perfect partner.
Thank you
And
for inviting me.
yeah, sure. And see everyone in the next episode of this. And take care. Have a great
Bye-bye.
weekend. Bye bye.